Yeah, hello. I trust you are all doing so well. Today we'll be looking at the internal structure of the Earth. And looking at the diagram over here, you would uh, realize that it's made up of four layers. Before I continue, I once had an experience where some of my students thought that we were actually inside the Earth, not on its surface. But later on, they corrected that assertion because from what we are about to learn, you'll get to know that the inside part of the earth is very hot, so there's no way any human being can exist over there. So first of all, you have the crusts. That's what we are on currently. That's the first layer. Then we have the mantle. That's after the crust. Then after the mantle, you have the outer core. Then after the outer core, you go to the inner core, which is the central part of it, central portion of the earth. So you have there's this diagram also on the right here. You could see exactly what happens. So the crust, mantle, then the liquid outer core. So we'll look at each layer. So let's start with the crust. So this is the outermost layer of the earth, as we said. This is where the soil and then the rock are found, and it is usually cooler as compared to the other layers, meaning that the other layers are hotter, very very hot. Some of them are very hot, and also the crust is thinner as compared to the other layers. It has a maximum thickness of about 90 kilometers. You could guess what the rest of the layers would be, far beyond that. Now let's take note of the fact that the crust is sometimes divided into two, or is thought of to be made up of two. We have what's called the continental crust, that's what's on the land. Then there is another crust called the oceanic crust, which is just beneath the ocean, beneath the sea. We call that the oceanic crust. Of course, beneath this crust, that is where you go to the mantle. Now let's take note that the crust contains minerals and then fuel, such as crude oil. That's where crude oil and then minerals are obtained. Aluminium and the rest, they are obtained from the crust. Then the mantle is just the next layer after the crust as you go deeper inside the earth, and it is about 2,900 kilometers thick. So you could understand why we're saying that the crust is the thinnest, because the crust is just about maximum thickness. You would have to appreciate the fact that it's not even around the earth. So at certain portions you would have the crust being less than 90 kilometers, at certain around maybe 30, 40, 50, but its maximum thickness is about 90 kilometers. But when it comes to the mantle is about 2,900 kilometers. So that's very thick, very very thick. Now let's take note that the higher pressure around this area causes the formation of minerals within the mantle, and also earthquakes are caused by a sudden rupture of the mantle. When the mantle breaks open due to movement of the plate of the earth, that's what causes earthquake, as well as the crust. If the crust also has some rupture, it also leads to earthquakes. Now let's take note that igneous rocks, which are also one type of rocks, they actually emerge as magma, as hot liquid rock, which comes from the mantle. Then when they get to the surface of the earth, because that's around the crust area, that's very cool. The coolness will now sort of solidify this magma into the solid igneous rock that we have. So most igneous rocks, as we know, or igneous rocks are actually formed this way when magma from the mantle is solidified on the surface. Alright, so let's move on to the outer core. So the outer core is after the mantle. So after you have passed the crust, you go to the mantle. Then after you pass the mantle, you now move to the outer core. Now the outer core also contains iron and nickel, and it is liquid in nature, so it flows like just like liquid. Now let's note that mantle is solid, but however it's able to flow like a thick semi solid, a thick fluid. But however, the outer core is purely liquid in nature, so it flows around the inner core of the earth. And this movement, now let's take note that it's entirely metals. Now this movement of these metals creates something like an electrical current, and this electrical current, because it's moving around the inner core of the earth, which is made up of metals, it creates a magnetic field. Now one of the things that you will learn in science or in physics is that whenever electrons move around a metal, a magnetic field is generated. It's just like the way electromagnets are generated. When you pass electricity through a metal, it generates, or it turns the metal into a magnet. So that's the same thing that happens to the earth. So the earth acts as a magnet due towards the flow of the outer core around the inner core, creating a magnetic field around the earth. That is why you would have the pointer of a compass always pointing to the north pole of the earth, because the compass has a magnetic component which will always align to the north pole of the earth's magnetic field. Now let's move on to the inner core. The inner core is a huge metal ball, and it is mostly iron, just some few other elements, non-metal like sulfur and all that. Now it also contains radioactive elements which decay, and then they generate great heat within the inner core. Now its temperature is about 5,000 degrees Celsius, so you could understand where this high heat is coming from. It's coming from the decay of the radioactive elements. Radioactive elements are those elements that are used in making atomic bombs and those things. And you see, when those bombs explode, you see the fire, you see the heat which is generated, very high amount of heat. And that is exactly what happens within the inner core, generating about 5,000 degrees Celsius. So deep down the earth in the inner core, there is high heat over there. But that is, is very far from us. We've been on the crust, so we don't feel that heat. So this means that the inner core is actually the hottest part of the earth, and it is solid in nature. Maybe you'll be wondering, why is that the outer core is liquid in nature, is able to flow around the inner core, but the inner core is solid. Now the reason is that, you see, whenever you have any hot substance, let's say a hot liquid, if the pressure above the liquid is very high, that liquid will never turn to vapor or to gas. In the same way, when you have a hot solid, when the pressure above that hot solid is so high, it will never melt. It will be difficult, it will take a long time for it to melt. So in the same way, the high pressure from the surrounding layers upon the inner core prevents it from melting, as it were. So it still remains liquid regardless of its high temperature. Now let's look at some few questions to just to assess ourselves. First of all, the crust is thicker than the mantle. True or false? So that is false, because the crust is just maximum 90 kilometers and the mantle is about 2,900 kilometers. So obviously that's false. Now the hottest layer of the earth is the inner core. True or false? So that's true. A temperature of about 5,000 degrees Celsius. The most prominent metal in the inner core is iron. That is true. It is mostly iron. Heat within the earth is generated by the sun. That is false. It's generated by radioactive elements within the inner core. Going deep down the earth, the layer just after the mantle is the crust. That is false. The layer just after the mantle is the outer core. The magnetic field of the earth is created by the rotation of the outer core. That is true, because the outer core is liquid in nature. As it moves around the solid inner core, it generates that magnetic field. Then also the inner core is liquid, just like the outer core. True or false? So that is false. We just answered that, because the inner core is solid. Alright, so thank you. I'll see you some other time.